So first off, you would note that anytime that x equals -1, the value of our differential equation should be 0, as long as y isn't 0, but y equals 0 has no points here for us to deal with. So anytime where x is -1, we should have horizontal lines there. That's your first point. 1 point. All right. And then you plugged in places where x was 0, which made your numerator 1. So 1 over 1, 1 over 2, 1 over -1. Oh, that was awful looking. 1 over -1 and 1 over -2. Then we put it in places where x was 1, which made our numerator 2. So 2 over 1, 2 over 2, 2 over -1, 2 over -2. So that's about what our slope field should look like. All of the rest of these points here was worth a second point. And then it asked us to sketch the solution curve that goes through 0, -1. And it's going to go along just like that and eventually become horizontal to get closer there. And that was worth a third point for sketching the curve. Good or no? All right. Part B, if dy dx equals -1, that's going to tell me that -y equals x plus 1, or y equals -x minus 1. So all of the points for which the derivative is -1, they all fall on the line y equals -x minus 1. And that's all you had to do for part B. And was just kind of give a description of those points. And the best way to give a description of them is say what line they all fall on. And that was worth 1 point. Any questions there with part B? All right. Part C. First, we separate the variables, which looks like this. 1 point. Second, we integrate. Second point, we don't forget our plus c. Third point, we plug in our initial condition. Oh boy, what was our initial condition? That when x is 0, y is -2. So we got -2 squared over 2 equals 0 plus 0 plus our constant gives you a constant of 2. Fourth point. And to get your last point, you successfully solve y squared over 2 equals x squared over 2 plus x plus 2. Multiply everything by 2. Gives us y squared equals x squared plus 2x plus 4. And then square root. And when you square root, you got to recognize that you can get a positive or a negative value in front of that square root. And so we need to look back to our initial condition. Our initial condition said that this needs to go through the point 0, -2. And so do we need the positive or do we need the negative square root so that when we plug in 0 for x, we get -2 for y?
Negative.
Wonderful. And that is your final answer. And that is your 5th point there for that one. Any questions on that first question? Did you guys do okay with that one when you worked through it last night?
Yes.
All right. I believe this was our next one. That look right?
Yeah.
Wonderful. All right, part A. Write ourselves a tangent line to f of x at x equals 1. So to write a tangent line, we need a slope and a point. There's our point. And our slope at 1, 2 should be 1 times 2 cubed, or 8. There's 1 point getting the slope. And a second point for writing y minus 2 equals 8 times x minus 1. Everybody good there with that one? All right. Part B says use that to approximate f of 1.1. So y minus 2 equals 8 times 1.1 minus 1. Or y equals 2.8. That's worth 1 point. Then it says, given that the function is positive from 1 to 1.1, is our approximation greater than or less than 1.1? So in order to figure that out, we've got to talk about the second derivative. So we're going to look at the second derivative at the point 1, 2. So, well, not even just at 1, 2, but we're going to just look at our second derivative, which was, I forgot what it was, y cubed and 1 plus 2x squared y squared. And so it tells us that our function f of x is greater than 0, which tells us that y is greater than 0, or x less than 1.1 greater than 1. And so x is positive and y is positive. So if both x and y are positive, this second derivative is greater than 0 for x between 1 and 1.1. If its second derivative is positive, it's concave up. And if it's concave up, the tangent line will be less than the actual value. Good or no? Any questions on that? Yeah, you can always simplify it out if you want to, like so if you wrote 8x minus 8 and then added the 2 8x minus 6, that's fine. There's no reason to do that. They're not going to like give you a bonus points or anything. So my suggestion is not to do that because you might make an arithmetic error. But it's up to you. All right, part C says solve with the initial condition f of 1 is 2. So first thing we'll do is separate the variables. So dy over y cubed equals x dx. X, yeah, x, okay. And so we'll integrate. Integral of y to the -3 is -1 over 2y squared. Integral of x is x squared over 2, plus our constant. So we've already got 1, 2, 3 points here. And then plugging in our initial condition to get our fourth point. X is 1, y is 2, so negative 1 over 2 times 2 squared equals 1/2 plus c. This is negative an eighth, and we're going to subtract a half from negative an eighth. So negative 1/8 minus 4/8 ought to be negative 5/8 as our constant. And that's our fourth point. Negative 1 over 2y squared equals x squared over 2 minus 5/8. And then we're going to multiply everything by 2. Just to start with. X squared minus 5/4. If you want to get a common denominator, you can, or you can just write this as 1 over x squared minus 5/4. Then you're going to divide by the negative. And get y equals the square root of 1 over 5/4 minus x squared. Then we have to decide if we want the positive or the negative. This time, based on our initial condition, we want the positive, and that's your fifth point. Any questions there on that? All right, and then this is the last one that I asked you guys to take a look at, right?
Mm-hmm.
All right, so there's a coffee pot, it's got a radius of 5, it's got a height of h. They tell us that the volume of the coffee is changing at negative 5 pi root h. They give us a volume formula, pi r squared h. They want us to show that dH/dt is negative h over root 5. Well, that should be easy enough because negative 5 pi root h, that's dV dt. And just indicating that somewhere within the problem was worth a point. But then you would have taken your volume equation, volume equals pi r squared h, and taken the derivative with respect to t to get dV dt equals 2 pi r dH dt. And we're trying to find dH dt, so we'll plug in our dV dt. And that gives us 2 pi times our radius. That's yeah. Bad by me here. R is not a variable in here. This is 25 pi dH dt. We need to plug our R, which is constant n, first. Sorry about that. So 25 pi dH dt. We'll divide by the 25 pi to get dH dt equals negative 5 pi root h over 25 pi, which is negative root h over 5. And this was total worth 3 points, 1 for getting this somewhere in there, 1 for this, and 1 for showing the final thing. Any questions there on part A?
No.
All right. Part B then says that we need to solve the differential equation dH dt equals negative root h over 5 with the initial condition that at t equals 0, h equals 17. So then we'll separate the variables here. Sorry about that. I had to talk to my kid for a second. Dh over root h equals negative 1/5 dt. And we'll integrate. Dh over root h just becomes 2 root h. Negative 1/5 t plus a constant. And 2 root 17 equals 0 plus c. So our constant is 2 root 17. And 1 point for separating the variables, 1 point for the integration, 1 point for the constant being there, and 1 point for using the initial condition to find it. And then we've got 2 root h equals negative 1/5 t plus 2 root 17. Root h equals negative 1/10 t plus root 17, and h equals negative 1/10 t plus root 17 squared. And there's your 5th point. Any questions with that? We feeling pretty good about these overall? Part D then said, when is the pot empty? So that'd be when is h 0? So when does negative 1/10 t plus 17 squared equal 0? Well, that'd be when negative 1/10 t plus 17 equals 0. Or, sorry, not plus 17, root 17. That'd be when t equals, subtract the root 17 is negative root 17 and multiply it by negative 10. It would be 10 root 17. And that was 1 point for part C. Any questions at all on that? All right, cool. So, looks like we've got some time here. Don't want to do that one or that one. I think we're going to do this one. So I'm going to give you guys 15 minutes to work through this one. I believe it is on page number 14 in your PDF that I posted. Page 14, but it should be this problem right here. So I'll give you guys 15 minutes to work through it, and then we'll talk about it, and then we'll probably be done for the day after that. So everybody good? Everybody found that one in the PDF if you do it that way, or got it right here in front of you? So, all right. 15 minutes starts now. Ready, go. We got the differential equation y minus 1 squared times cosine pi x. We're going to sketch our slope field. We would note that anytime when y is 1, this whole thing is going to be 0. So those are going to look like that. If we plug in 0, 0, that's going to give us negative 1 squared, which is 1. And then the cosine of 0, which is 1. So it should look like that. And I guess we should probably finish up. We'll just do all the ones where y is 0. So that's going to be 1 for each of these. So really, we're just looking at the cosine of pi, which is negative 1. And then the cosine of negative pi, which is also negative 1. Then when y is negative 1, this is always going to be 4. And then 4 times 1 is going to be positive 4. And then these will both be negative 4s. Does that look about right to everybody there? How do we feel about that? 1 point for those ones and 1 point for those ones. And then it says we got a horizontal line that has an equation y equals c that satisfies this differential equation. Well, what's the value of c? Looks like c should be 1. Because if I were to sketch the line, y equals 1, it sure looks like that's a pretty good solution to that differential equation. So that's 1 point for part B. Everybody good with A and B? Any questions on A and B?
So you didn't have to calculate anything for B? You could just draw a line and say, look at the slope field?
Yep. Correct. All right, for part C, we want to find the particular solution given this initial condition that when x is 1, y is 0. So we're going to first separate the variables. So dy over y minus 1 squared. And then we got, what is it? Cosine pi x dx. So there's 1 point. Integrate both sides. This one just becomes negative 1 over y minus 1. That's 1 point. This one becomes 1 over pi sine pi x. That's 1 point. Plus c. That's 1 point. And then plugging in your initial condition, which now I forgot, 1, 0. So that gives us negative 1 over negative 1 equals 1 over pi times the sine of 0 plus our constant. So our constant is 1. That is a 5th point. And this one had 6 points for finishing off the solving. If we distribute the negative through there, that's 1 over 1 minus y equals 1 over pi sine pi x plus 1. If we get a common denominator here, that'll be pi over pi instead of 1. And so when we flip it, we end up with 1 minus y equals pi over pi plus sine pi x, or y equals 1 minus pi over pi plus sine pi x. And that is the 6th point for part C. Any questions on that? Any issues, any questions? Everybody feel okay about that one? All right. Yeah, negative 1 over y minus 1, that's what we had. So negative 1 over y minus 1. And then you must have missed it when I said it. I just said that we'll distribute that negative sign through, which if you distribute the negative sign through, the opposite of negative y is positive y, and the opposite of positive 1 is negative 1. So just 1 over 1 minus y. Same thing.